First of all, welcome everybody to the latest in a series of webinars being presented by the Urban Big Data Centre. This session, hopefully you're not surprised to see, is entitled Practical Approaches for Web Scraping using Airbnb data and the UBDC Airbnb scraping platform. My name is Andrew McHugh. I'm the Senior Data Science Manager at the Urban Big Data Centre, and I will describe what we do as a centre in the following slides. But I'll ask my colleague Nick Vess, who's the architect of the platform we'll showcase today, to introduce himself just now as well. Nick.
Hi, good morning all. I am a data scientist. I'm working with the UBDC under Andrew here. And yeah, it's my pleasure that you guys come over here. We are going to present you later on the way that we've been using to capture data from the Airbnb. So hope you all enjoy it and welcome.
Thanks, Nick. So got a relatively kind of packed agenda today, but I want to start with some housekeeping. The session is being recorded, as you'll no doubt have been notified when you joined the Zoom session. So an edited video will be published on UBDC's YouTube channel in due course. That's the YouTube link where you'll find all Urban Big Data Centre video content, but just obviously to bear in mind that is happening. All slides that we'll present today will be made available to course participants, as well as the code that will form the major part of today's focus, also all accessible. Questions can and we encourage you to send those in via the Zoom chat. We will have time at the end, and we'll also take some time in the middle of the session to cover those, but they will be monitored throughout. So if you have small technical questions or bigger questions, we'll tackle those at the appropriate times. And we ask obviously that people keep mics muted throughout the session, and the principal form of interactivity will be through the Zoom chat. Okay, so just to summarize what we'll be covering today, you'll have seen the sort of intended learning outcomes already perhaps, but following today's webinar, we hope you should be able to accomplish a number of things. And the main focus, the principal focus today is UBDC's open source platform for scraping Airbnb data. So you'll be able to describe the installation, configuration, and deployment of that. And later on, having to grab the code for yourself, you'll be able to recreate that within your own environment. You'll be able to explain what web scraping means in very broad terms, understand what the key legal, ethical, and data governance issues associated with web scraping are, summarize some limits on data use and sharing, to identify and select appropriate data sets for web scraping, understand what an API is, learn how to negotiate some of the technical barriers that we associate with web scraping, and lastly, to systematize, scale, and optimize your approaches. So as I say, this will be principally through the lens of our own implementation, our own scraping platform. But hopefully the lessons and the learnings that we describe will be applicable to other kinds of problems that you may be tackling. In terms of the program, we're here for 2 hours today. We're in the first of those agenda items at the moment. We will have a talk that follows. I will lead you through some of the background to this work before handing over to Nick for the main part of the agenda, which will be a technical discussion of how we've approached the scraping problem and how we've implemented a platform, and laterally, of course, how that platform works and how you can use it yourself. And as I said again, encouraging as much discussion and questions as possible to try and ensure that this answers any of those questions that may arise or that are already on your mind. Before we get started, I wanted to draw your attention to just one other webinar. I mentioned that this is the latest in a series of UBDC webinars. We have another one later this week on Thursday, 24th of June at 10 a.m., which is something of a companion piece to this one. Whereas we focus today on how you go about accumulating collections of data through web scraping, we'll have a companion session on Thursday, led by my colleagues Mark Livingston and Yang Wang, and they will be focusing much more on how you actually use the Airbnb web scraped data to undertake some pertinent research questions and research challenges. So that takes place on Thursday. You can visit the UBDC website for more details and register. And again, like all of these webinars, that's free to participate in. So moving on, I'll offer just a wee summary of what the Urban Big Data Center does, because again, it may give you some context, and it may make some of what follows a bit clearer. We're based at the University of Glasgow in the United Kingdom. We are funded by the Economic and Social Research Council, which is a UK government funder of social science research and associated infrastructure, as well as receiving some funding from the University of Glasgow itself. We've got several priorities, which are associated with two principal functions. So we operate a traditional research center focused on better understanding cities and relying on the use of new and emerging forms of data and associated methods to enhance our understanding of how cities function and how their residents behave and interact. And we also offer, on behalf of the Economic and Social Research Council, a national data service where we support other, mainly academic researchers, exploring similar themes in similar kinds of ways. But amid that, we have these priorities around data infrastructure and collection. So we're very actively developing our data infrastructure and associated data collections. We support a number of priority research strands within the center, although not exclusively for those that we support externally, but those include things like transport and mobility, neighborhood housing and environment, education skills and productivity, and some of the more umbrella questions, if you like, around the role and value of big data and urban governance. And our aims are to achieve public policy impact, to critically evaluate the role and the value of big data and urban analytics, and to enhance the data collections that we create and collect and the associated methods for their use. And all of these various different functions and priorities often come back to or rely upon the availability of data, and getting hold of data is, as you can imagine, and no doubt many of you have experienced, can be quite a challenge at times. It takes up a lot of our time to go out and not only identify data, but to develop means by which we can get hold of that data, and that can imply a range of technical challenges as well as obviously legal challenges and so on. And obviously there are many reasons why organizations don't make their data available or are not do not feel incentivized to do so, include a lack of capacity to do so, perceptions of risk, perceived conflict with existing business models, or for example, making data available may undermine business models which involve the provision of data on a commercial basis, or other kinds of conflicts. And fears too that research results may reflect badly on them or expose them to criticism or be received negatively by other stakeholders. So that last point is probably one that we focus on most in the content that follows, and in our particular case. And while there are many reasons why we feel we can encourage organizations to make their data available, they don't always work. So sometimes we have to find other means of getting hold of data that aren't quite as collaborative as for example, a licensing agreement or a collaboration agreement. So Airbnb is obviously the focus of today's session. It provides us the lens through which we're looking at the technology discussion that will follow later on. So I thought it'd be useful again just to give you a little bit of a summary of what we were looking for and for what reason. Start with a very, very fundamental point. So many of you will have no doubt be familiar with Airbnb, no doubt have used their services in the past yourself, but it's an online marketplace for arranging or offering lodgings, homestays, and tourism experiences. So you can go on to Airbnb and perform one of several roles, the most obvious ones being there are hosts, there are people that own properties or that manage properties on behalf of others who use Airbnb as a platform to promote the availability of these homes or lodgings for tourism or for other kinds of accommodation purposes. Meanwhile, there are a other set of people who are on Airbnb much more from a consumer point of view, people who are interested in finding a holiday home, finding somewhere to stay for a short-term basis. And they will discover the available Airbnb homes or venues or accommodations via that platform. Our researchers were looking at Airbnb and were particularly interested in some of the impacts of Airbnb and the sort of rapidly growing sharing economy that it's a really important manifestation of. What are the impacts of that? What's the importance of that for the private rented sector property market? So how does this impact on more traditional private rental? How we hear of these things obviously as being very disruptive, and we wanted to be able to sort of characterize and understand what those disruptive impacts actually are. And question two, the extent to which they are positive or potentially damaging. So some of the questions that are foremost in our researchers' minds, the impact that Airbnb has on the availability of private rented stock. So given the opportunity to market and sell properties, or rather sell access to properties on Airbnb, does that limit the amount of private rental stock that's available on a more traditional basis? Is there a spatial aspect? Are there particular locations or areas that see a greater or lesser impact of these changes? What, if any, is the relationship with areas of social deprivation, and does the rise of the sharing economy increase things like inner city gentrification and the suburbanization of poverty? So things that we would often associate with negative outcomes. Are Airbnb properties falling below the standards for the private rented sector, e.g. in terms of occupancy levels? So where there's a regulated environment, are there standards that are not being met? Is this providing a loophole for substandard service provision? And what impact, if any, does Airbnb have on the existing hospitality industry as well as private rented sectors? So as you can no doubt imagine, and I won't go into these in any more detail than that, you'll see perhaps some more coverage of some of these specific research questions and how they are tackled and resolved in the later webinar on Thursday. But these are really just presented just to show that these are not necessarily research interests or goals that will resonate with Airbnb as being something they are keen to get involved in. They may not be enthusiastic about facilitating such research, which may have the potential to lead to outcomes which may be critical of their business models and so on. But given their the possible lack of enthusiasm about making data available, we have to look to sources elsewhere. And unfortunately, as an unregulated sector, there is little reliable data available. So we have to think creatively about how we can get the data that will give us the insights into how this model works and what its implications are. So we wanted to automate the scraping of Airbnb as an online marketplace. The data is available on the web. It's accessible freely. And we wanted to effectively industrialize the collection of data from that platform on a very systematic basis in order to facilitate our research. And an obvious initial starting point was the legality of our proposed data collection. To what extent are we legally entitled or permitted to go and collect data at scale from Airbnb in that kind of way? I'll cover that in some slides in a moment or so. But then if we're able to reassure ourselves that we are legally permitted, we have a sound legal basis for proceeding in that particular way, can can we then develop methods and can we design our data collection to support questions around the scale and growth of Airbnb, spatial change, focus on short-term lets. So how can we see the changes manifest on a spatial basis? Can we understand how occupancy works? How many people are occupying particular Airbnbs at a given time? Can we understand price and the changes in price and what some of the determinants of price and the things that influence price, and availability as well? So these are things that we may feel that are self-evident within the data to some extent, and when we go onto Airbnb, we feel we can sort of infer some of these things on a limited basis but can we capture these at scale and achieve a robust and a credible understanding of some of these things? So that will frame how we actually go about doing the scraping, which we'll see later on. But again, before going there, I think it's important just to cover some of the fundamentals. And the first is just to offer a definition of scraping itself. So I already mentioned in the past that we go out and get data from a variety of organizations in support of our research. And very often that can be a very collaborative thing. It can be a very explicitly consensual thing, with things like license agreements and so on. Scraping is comparatively a one-sided activity. It's about taking data that exists, for example, on a website, and employing any one or combination of a range of different technical means to automate the transfer of data from that location or resource. And there's a whole range of methods that can be done to facilitate that. So with online data, we can employ techniques like text pattern matching to grab particular types of data and to then impose some kind of structure on those at the collection end. We can use things like HTTP programming, and that will be the primary focus of what we do, relying on the Airbnb API, as Nick will outline later on. We can rely on the existing structure that is implicit within web content through HTML and the document object models, and effectively parse through that marked up content to extract particular data, and then obviously impose structure or transpose from the structure already evident. And we can use a whole range of other more sophisticated techniques too, like computer vision, for instance, where we're actually analyzing the visual representation of web content in order to extract particular parts. What's, I think, true of all of these approaches, and it's very core to this, the philosophy or the technical philosophy of this approach, is that it's unsupported by a web content owner. The very fact that you're doing this is probably because the web content owner is resistant or are unable to make the data available under a more cooperative model. That means that while it may work very well one day, it might be prone to break in the event of things like changes to websites. Then web scraping technologies can fall down. They are quite comparatively brittle in that respect. And there can be a whole range of different website controls in place too to limit one's ability to do things like scraping. Those can include common controls that are implicit on many websites that are designed to block nuisance hosts. So when you start doing things at scale, when you're accumulating a lot of data, then the behaviors as far as the website is concerned may look like a nuisance host, like behaviors akin to denial of service attacks. You need a lot of requests in a very short space of time, and there can be controls in place to blacklist those nuisance clients or those identified as nuisance clients. And obviously, as well as technical measures like those, there can also be contractual measures, so terms and conditions of websites that explicitly prohibit people from doing web scraping activities. And as we'll see, there may be those explicit contractual measures, but likewise, there are other parts of the law that offer us some encouragement and some reassurance that those contractual measures may not be applicable. We'll cover how we resolve all of these types of issues in the slides that follow. There are some alternatives to scraping, of course, and even without the active participation of Airbnb themselves, there are some existing online resources that we have reviewed and assessed. Two prominent data providers are Inside Airbnb and AirDNA. The former is mostly the fruits of data collection efforts undertaken by a small number of people who focused on particular geographic areas and in particular prominent global cities, and sought to kind of build a picture using a range of different scraping tools. AirDNA is a commercial platform where they will actually provide access to data at a commercial cost. But our view, having reviewed these, is that they do tend to suffer from a number of shortcomings, principally around things like limited sampling. So for instance, while Inside Airbnb offers interesting data and it's been a useful means of calibrating and validating some of our own data collection efforts, the sampling is quite limited to particular specific global cities, which don't necessarily intersect with those areas of interest that we have within our research agenda. There are data quality concerns at times, and also I think with AirDNA specifically, there was uncertainty at times of exactly how data was being collected, and a sort of issue of black box processing, which from a research perspective is particularly unattractive, because we want to have a degree of reassurance that the data we're getting and the calculated variables or the inferred variables that are being presented within data sets, we have a good understanding of how those are arrived at. In particular, our understanding of occupancy, price, and availability, which are very key to our interests, it was not clear how the data related to those types of features was arrived at in the AirDNA platform. So our view was, well, we'd be much more comfortable with developing our own data collection approach that much more directly relates to and aligns with the research needs that we had identified. So how do you begin to develop a scraping approach? Well, there are various open source projects out there that we initially evaluated, and for example, with the Inside Airbnb platform, there are links to corresponding code bases that where effectively you can deploy their tool sets in different locations on different kind of schedules. But we've reviewed a number of, and that's the first link here, the Airbnb data collection project. But for each of those that we reviewed, we determined that there were problems and challenges with, for example, code bases that had not been updated, that we were struggling to deploy successfully, and we became increasingly aware of a different approach that we were keen to adopt. So these projects here, well, the first link here, Airbnb data collection, it's grabbing data directly from using the document object model, I think. The latter one here, HTTPS request randomizer, is a project that allows you to effectively distribute requests across a number of different proxy hosts in order to not fall foul of some of those website controls I described earlier on. We've devised our own alternative approach that covers both of these things that Nick will be able to explain much more comprehensively than I can. But again, we mentioned the issue of legal and ethical issues, and again, it's important to resolve these and to feel reassured that that we're not falling foul of ethical or legal expectations in order to undertake this kind of data collection work. Unfortunately, despite being hopeful that there would be a very clear and unambiguous legal basis, a lawful basis for us to proceed, we're still very much involved in a broader effort to achieve clarity there that is probably going to prove elusive for a little bit longer. So we're based at the University of Glasgow, and we worked with the Create Centre, which is also based at the University of Glasgow, to better understand the legal landscape that relates to online scraping. And as I said, unfortunately, the picture is not wholly clear. So we were initially alerted to something within copyright law called the text and data mining exception, which effectively, as from a layperson's perspective, provides a provision whereby for academic research, one is permitted to collect at scale data that is made publicly available, that is covered by copyright, but that is nevertheless made publicly available. So you have legal access to that. And under this particular exception, you are lawfully permitted to collect that data and to use it as the basis of academic research work. Now that is a right that is not that cannot simply be ruled out through the use of contracts and terms and conditions. So it's not possible to contract your way out of that situation from Airbnb's point of view. So we learned of this and took this to Create and felt relatively reassured that this would provide us our lawful basis to proceed. But unfortunately, the issue is not quite as clear as we'd hoped, because in addition to copyright law, there are a range of other different legal regimes which each intersect here, including privacy, including contracts and confidentiality, and other intellectual property rights too, which themselves appear to be operating somewhat in a somewhat contradictory fashion. So although we can look at copyright law and feel relatively reassured, there may be other relevant legal precedent from other legal regimes that would cast some doubt in terms of the lawfulness of what we wish to do. Ultimately, until case law emerges, this therefore remains a risk-based policy decision. Do you do this? And it's on the basis of a risk-based decision. And some of the factors that we've considered and felt relatively reassured about, having reviewed in great detail the case law that already exists, there's very little, if anything, that feels relevant to our particular setting. It's obviously from a lot of different commercial environments, and clearly our agenda is not to achieve some kind of commercial outcome. Rather, we're seeking to deliver academic research that will lead to that will be influential to policy, perhaps, but without any kind of commercial expectations. Similarly, we look to other academics who are doing similar work and feel relatively reassured that there are an emerging code of practice around how one approaches this stuff responsibly. The work that we did with Create has been written up into an initial working paper, which is linked to here, and you can see a DOI. And I would encourage people to familiarize themselves with the law of data scraping, and it's work that we're very much continue to develop, because there is a really important part here. We'll talk about some of the ways that Nick has innovated in very technical terms to achieve a means of data collection, which will hopefully be the basis of some quite transformative research. But the innovation space here is not limited just to the technology, of course, and within the legal environment, there is a great deal of opportunity for us to leverage things like the text and data mining exception, but more importantly, to leverage our understanding of the law and where we can innovate, where we can remain at all times on the right side of the law, and with a community effort and with developing a community-wide coherent approach where we may seek to influence the law too. So the law is ultimately playing catch up a lot in these technical issues. And therefore there's a real opportunity for us to assert how the law should behave and how the law should reflect what is happening technically. And that's very much what we're in the midst of at the moment. But we felt reassured, having gone through this process, that the risks were within our risk tolerance, and therefore we're comfortable proceeding. But ultimately, this is a decision that should be taken with a high degree of consideration within your own institution. I wanted to touch to just some of the other legal and ethical issues associated with these data. And as you'll see later on, when Nick sort of showcases our platform and showcases what data we are focusing on, there are a range of things that you can collect from Airbnb. Those can include pictures of hosts. So, I mean, these are not necessarily pictures of individuals, but rather the sort of the thumbnail image that they will have included. Potentially to further information about hosts, what they've included in their about me type statements, which may or may not be personally disclosive kinds of information, physical locations of where the properties themselves are. So the data, while we focus on the benign data, the data that we don't consider to be disclosive, there are things in there that one can potentially collect that may be disclosive. It may draw questions around that associated with privacy legislation, for example. There are also ethical questions around how we approach the practical aspect of scraping as well, and specifically how we negotiate some of these controls that are intended to limit the effects of nuisance hosts. We circumvent those by distributing requests across a proxy host network. And again, within the copyright law text and data mining exception, there are important distinctions drawn between controls intended to protect the copyright of any content that is hosted, and any controls or protections that are intended to safeguard the stability and the functionality of a given website. And we effectively interpret the controls that Airbnb have in place as being for the latter, and that is our circumvention methods are therefore consistent with the text and data mining exception. But there are legal, well, if not legal questions, there are legitimate questions that may be posed. Clearly, when you're doing scraping at scale, there are costs that are being incurred by the data owner themselves on their platform. Bandwidth costs, the most obvious one, and these are questions that are at present not completely resolved. I'll close in a moment and invite any initial questions that we may have. But I'll sort of present this slide here around challenges that Nick will pick up later on as well. But these are some of the things that we had to tackle when approaching this particular project. So obviously with a scraping approach, I mentioned that the one of the most overwhelming kind of characteristics of this data collection model is that it's a very one-sided approach. It's not in any sense a cooperation, and in that sense that there is a lot of guessing that goes on. We have no straightforward means of looking up what data means and what they represent, the data that we capture. It's difficult for us to understand the ways that data are published and managed within Airbnb's online environment. We have also challenges that we need to manage at our own end as well, as we get more understanding of the data that's available and more understanding of what the data may or may not represent. It evolves our specification of our needs. So, more understanding might let us refine our statement of what we actually need, and then we may have to therefore revise our methods to ensure that we collect more data if and when that need emerges. Airbnb is obviously not a static resource either. They're just as prone to change, and obviously technical development and innovations that may take place on their end, or indeed additional controls to to limit the kinds of activity that we're involved in that they may consider unattractive. So we need to make sure that we are dynamic and aware and keeping up to date with some of these changes, as well as, you know, from an expectations management point of view, acknowledging that there may be changes ultimately that follow that break everything we've done, or that render our efforts completely undone. There's also obviously service levels and service limitations that the Airbnb have in place that we have to think about how we negotiate. There are limits to the number of results, for example, that may come out of searches that we rely upon. So that obviously impacts how we do things at scale. And on that same issue of scalability, it's very important that if, for example, our target is to be able to collect data on a daily basis, our approach that's designed to do so has to be completed within a single day in order to ensure that it's ready to go the following day. And the last point is around historical data as well. We're grabbing data that represents the status of the Airbnb platform at a particular time on a particular day. So there is no obvious means by which we can capture historical data. So as we'll look at, for example, how we approach the capture of data from Airbnb calendars, we want to see on every single individual day, what is the status of the calendar for the forthcoming period of time, in order to then get a better sense of when things were booked and when those calendars changed and so on. But we can't get a picture of what that calendar looked like 2 weeks ago unless we actually did the scraping activity 2 weeks ago. So we have to, in order to build up a historical data set, which is, you can imagine, essential for many of the kinds of research applications we would have in mind, you have to be doing the data collection historically as well. But Nick will summarize how we tackle some of these in due course. The second part of today is very much around the UBDC platform. I wanted to mention just a note about how you can get hold of that. So it's on GitHub. It is available under the Apache license, which allows you to distribute, modify, and use. And we just require the original attribution notices to be preserved. So we do require people to obviously acknowledge the source of this particular platform, but we're really comfortable with people using it and adapting it to their own data collection needs going forward. So that was all I wanted to say for the first section. I will break now for a moment just to invite people to supply questions. I see that there are a few questions that have already been submitted. I'll have a wee read through each of these and try and offer a response. So the first I have here is, what are the rationale for stakeholders being fearful or not being collaborative in sharing data sets, as this would be useful if trying to gain access to other potential data sets? Well, I mean, that is very much dependent on the individual organization in question. I think with this specific example, I think the researcher colleagues had become aware that Airbnb would be very resistant to making data available. And the most obvious assumption in terms of why that would be is that the types of research that is often being undertaken, types of associated research, will quite often present Airbnb and these kind of business models in a relatively negative light. So there is little incentive for them to cooperate with research that they expect to present them negatively. I think Airbnb, it's fair to say, are within a whole range of different locations, along with other parts of the sharing economy, things, services, and companies like Uber. They do face resistance within particular locations. There is this inevitably the disruptive nature of these business models are such that they do elicit negative responses from some areas. And I think that there is an assumption that at least some of the outcomes of our research would be to be critical of these business models. As you can imagine, there are a whole range of other reasons why companies may be hesitant to make data available. The other obvious example we see from time to time are companies that are concerned when they engage with academic audiences with data provision, for example. They're concerned that the data may find its way into the hands of competitors, or it may be used on a commercial basis that would be to the detriment of themselves. You can find just as many companies that will say, well, actually, there's a lot of value in engaging with academia with data sharing, because it will enhance the data sets, it will enhance it will kind of establish the reputation and offer an endorsement of the value of the data that they make available. But there are many reasons, and they're often unique to the individual business or data owner. But I think ultimately the ideal goal is to try and offer incentives for sharing. But where you have research that appears so to be so kind of contradictory to a particular business model, it's challenging to see how you would achieve a more cooperative approach. What happens on IP and copyright law applies to other jurisdictions outside the UK? Has this been considering? What tips can you provide? So within, I mean, I should have already prefaced all of the coverage of the legal issues. Obviously, I'm not myself a lawyer, and nor is this legal advice. Our understanding, though, is that certainly within the European setting, there is a relatively harmonized copyright regime, and that continues even post-Brexit. Therefore, there are equivalent text and data mining exceptions across individual legal systems throughout Europe, for example, which in some cases offer even more robust opportunities for academic researchers. I mean, a lot of the questions around the specific legal advice here, though, are quite technical and probably not something we should spend too much time here on, nor am I don't think sufficiently well placed to kind of comment authoritatively. But this issue of kind of the intersection of different legal regimes and the apparent kind of contradictory nature of what they say does present challenges and presents problems, and it has the potential to offer a kind of paralyzing effect on researchers who want to do things in good faith, but they want to do things ethically and on the right side of the law. One of the key questions here is, are the data that we are collecting from Airbnb themselves covered by copyright law? Are they which you may think, if the answer is yes, you may think that means they are more protected and therefore less accessible to us. But the converse is actually true, because it's only if they are covered by copyright law, then this exception applies. Whereas in the case that they are not covered by copyright law, then this text and data mining exception would not apply, because it's not a copyright issue. So there are complexities. There's no precedent that really speaks to the specific circumstances we're doing, or indeed general questions around the legality of academic research using text and data mining exceptions as their lawful basis. So we will not quite wait and see. What we're keen to do is work with others and work with legal scholars too, to come up with what we think is a code of conduct, a code of practice that we would like to see becoming manifest within the law and the interpretation of the law. Next one, can policy really be separated from commercial outcomes? It's a good question, and it's difficult to we deal a lot on obviously a range of different licenses, and the issue of what is and is not commercial use of particular data sets is a perennial challenge, and there remains no clear definition that we think is completely watertight. I think that you're right. We don't seek to benefit commercially ourselves, and that's perhaps what we would have at the heart of our own internal justification for this, or rather our own kind of rationalization of risk. I think that in that respect, that kind of the goal of the academic sector here is not to generate commercial value from these data. No doubt it may inevitably lead to commercial impacts on others who are operating within those kinds of environments. But from our own point of view, I think we feel relatively reassured that we're not establishing ourselves as a competitor to Airbnb, but rather we are interested in providing clarity of what some of the policy recommendations and some of the policy impacts of businesses operating like Airbnb are. If that isn't too fudgy an answer. How are you not to be seen to be a security threat? You know, I think that's the importance of some of the things that Nick will touch on briefly, I suppose, is how we ensure that we are not interpreted, at least through their automated controls, as being a security threat. You may argue that our methods are still kind of akin to what they may expect to see from people who would be security threats. However, again, we are comfortable with our understanding of what we wish to do with these data and the value that we want to deliver. So in that respect, our main priority is just to ensure that we don't set off the technical measures that would impede our efforts to collect these data. Even legally, there's no restriction scraping the content. Is there any legal restrictions on reporting findings? Well, this is an important point. So, and again, is something that we're really quite in the dark about. So it's a very, very good point. So the text and data mining exception is explicitly around data collection and the use of that data for research, but it says nothing at all of any, or certainly offers no real clarity about what you can actually do with the results of that research, what you might be able to republish, for example. So we can't, we feel fairly clear that we can't circulate the data that we've collected. So instead, what we're doing as a data service here is we're saying, well, let's promote our code, let's promote our methods, let's encourage other people to do the same kinds of things, or at least give them the means, the technical means, and some sense of some of the legal understanding to make a decision to do so. We can't share the data sets, though. That feels very clear. But what we can even publish within the context of a research article is, again, not spelled out in clear terms. So will ultimately be based on some kind of an informed risk assessment. And maybe you can make an argument, for instance, to say that implicitly, to do academic research work, you're going to publish, and implicitly, if you're doing academic publications within a certain setting, there are norms, there are expectations around what kinds of data should accompany the results within an academic paper. That's something we're still wrestling with, but again, it's an unfortunate lack of clarity around exactly what one can do with the data in terms of resharing, in terms of circulating, even within the context of a credible academic publication. So this area is mired in some uncertainty, and certainly in comparison with a very neat and elegant data licensing agreement where your permitted purpose is spelled out and signed up to, where expectations are explicitly managed and mutually agreed, that this is comparatively untidy, I suppose you could say, that this method of data collection, but it's a means to an end that would otherwise be very difficult to achieve. But we might. I'm not exactly sure what the program for next week for Thursday's much more research focused coverage is, but that is a very pertinent question within that presentation as well. Not just how do we get this stuff, but ultimately you need to be reassured that you can actually do with that data what you wish. Yeah, so this is the main part of the agenda now, where we'll see the platform that Nick has developed, and he will take it away. So thanks, Nick.
Hi all. Hi. Good morning. And yeah, I'm going to demonstrate this new the platform that we developed right here in UPC to scrape or capture the data from from Airbnb. Well, the objective of my part right here is basically to demonstrate how we set up a data collection service for Airbnb, and hopefully to kickstart anyone who wishes to do something similar. Now, a little bit of apologies over here because it's a bit awkward to share presentation and also the desktop that shows these steps. So bear with me for a little bit until I figure out how to share the screens. I need to do this one. So each one share. Okay, you guys can see my presentation. Yeah, hopefully you can. What I was trying to say, it's a little bit of history over here. It's that we were trying to capture the data from Airbnb, and as every problem, we tried initially a more direct approach. And no doubt that you're familiar on how Airbnb site web operates. It's that you have a search page where you put your query, and then you get the data. Well, something similar as we try like to do initially. It's like for its search result to go for its listings, and then for its listing to get the data from it, and extract the data from the HTML pages, and then check the database, and hopefully repeat. There's nothing wrong about this approach initially, but there's, as mentioned before, does have some limitations. Notably, the biggest limitation that you can find is that for quality reasons, the source, it's the Airbnb only returns 300 results per query per search. So they think that, rightfully so, that no one will go over. They need like a 300 results like to find their perfect match for their holidays. Usually users like a finding of whatever they want to find within the 50 or 60 results. So they don't bother going any further because it takes too much resources and to find all the listings that within their context. So high-end results. So high-end queries, it's out of the questions. For example, Edinburgh, if you put Edinburgh, it has 10,000 listings over here. So in the first iteration, you cannot find, through this method, you cannot find everything. And if you're like familiar with the with programming, it's one big linear approach over here. So if something breaks, it's within the search results, then you can't really restart where you pick it up, because every search result is a unique. Every time that you're searching something, their engine behind creates a ticket, and the results are unique for you based on the date, or based on where you are, based on the many different parameters that they have put down. And even if you were able to go around every that, it's Airbnb's, it's constantly evolving their model. Constantly they put in new features, or they're taking out other features. Like for example, we do have, if you recently been to their websites, they react about COVID. Is it that listing available to book in, to check in while this COVID situation? Is the UK government has rolled out any regulations about the COVID? So all of them, they need like to be reflected in their website. So it's constantly a game of mouse and cat here, where one's changing, the other needs like to react. And going for traditional methods over there, it's the biggest problem is that not the biggest problem. One of the interesting problems is that after you get the data from the HTML, it's that you are throwing it away. You don't keep it. So if you can't really compare what you have in the past with what we have in the future, what you will have in the future, or maybe you forgot to pick up something that you should have, and later on you figured out, okay, maybe I needed that, but too late. So, well, having these trying things in mind, and if if someone look very carefully in the website, it's not a static website. It's a responsive web application, basically, which is a combination of two elements. We do have the HTML element and the JavaScript element. The HTML code, basically, it's a placeholder, a template, where it's an initial starting page. It provides the cards, provides places where you put the information, and after it's loaded, it has a JavaScript code in the background where it kicks in, and then it starts grabbing extra information, and it started to hydrate the template to populate it. For example, when you load the website, and afterwards the JavaScript, it's requesting extra data from an API endpoint, for example, what listings there are within this context, and they get that listings, and then it makes sure to create extra HTML elements to show what's been happening. That's a very interesting concept. So basically one could do, so instead of going directly for the HTML code, which is like the end result, hijack or do the same thing what the JavaScript thing does, hit these API points, and instead of them letting them making the request the data, you are making them. So if someone is not very familiar with what is an API, basically it's well-known applications in the web where you are you are hitting them with your web browser, and them, instead of coming back with an HTML and XML document, they come back with a string which follows a JSON notation, which basically is a key and a value. So you got the ID equals the listing ID, the number. A listing ID equals the number that, or is available? Yes, no. Is it for what's the price for the day? That number, and etc. And imagine that you got like a very big string that it's representing all kind of information in this matter. So the easy way to talk with Airbnb is basically to use the API. There is, as mentioned before, you are hitting these endpoints with your browser. Alternatively, you could do that manually if you put some URLs in your web browser. You could do that, and you would get the appropriate responses. But alternatively, what usually you're doing within a programming environment is that you are letting your favorite language to construct this request, and then your language or your code is generating this request and grabbing the data for you in an environmental and programmatical environment. We have we started with, if you do a little bit of search in GitHub, there are like multiple libraries that they do that for Airbnb. They've been not updated like for a long time, or they've been abandoned, or they showcase that there is a constant evolution or interest of people trying to collect data from Airbnb. Many of them, they have their own limitations, other of them more current, but they paint a picture. And if you are interested in some in history, it's quite interesting. It shows that back in the day, Airbnb had a public API where it was sharing the data. It decided at some point to stop doing that, but it had published a white paper that was cataloging and explaining all their APIs, the endpoints that they had, and how you could request for access and how they were controlling it. That thing had been deprecated since then, but people using this information were able to collect all the data, all this knowledge into singular database, singular libraries. And the one that we started with, it was from this is wrong. This from another ones, for someone else effort, and we extended the model, the library, to do some extra stuff that we needed. And basically, this is and so basically, after you implement this kind of library, you can talk directly to the Airbnb. For example, like if you're familiar with Python, you import the name of the library, of course, like Airbnb. You're creating an API object, and then you get the data. For example, here's the new thing that we added is that you can get the data from this bounding box. It's give me all the data, and basically what comes back is a JSON, which this JSON has been then translated to a Python dictionary, and then you take it over with your code to do whatever you need to do. And what comes back, it's something very structured. This is another endpoint which gives back information about the details of the listing ID. So this ID, it has this coordinate, it's in this place, and has all the extra stuff that one might need or not. So that is like in the heart of what we're trying to do. It's like we have now a means of talking with Airbnb. So we build a framework, a web, not a framework, a system that around that manages and collects and scales and help and puts everything into more puts everything like in a more organized way to how to collect the data. So for our solution over here, obviously you can, I'll demonstrate what's been happening, but if you wanted to do it by yourself, obviously you will need some kind of pre-requirement. And the biggest one would be Docker. And since everything I try like to put it to make the solution as pain-free as possible. So if you're not familiar with Docker, basically what it does is create like a mini virtual machines where you are opening them as you see fit, as needed, and all the code, including the operating system, the parameters, the configuration, whatnot, the networks, already everything is resting inside this little bit of information. QGIS, we do need QGIS. I'm using it at this moment as a means to communicate with the framework from outside. Git, obviously, to QGIS, if you are not familiar with it's a GIS client, basically allows you to create geospatial features and do some geospatial analysis if you need to, but we're not going to do that. And Git, obviously, to download the code. And some other optional stuff that you might find useful. It's for me, at least, it's a database client that allows you all the data that comes from Airbnb are stored in the database. So it's nice to have something you can visualize that's been stored and extract the data later on and do some kind of transformation. And a fancy text editor where, as I said, the responses are coming back as a JSON notation. So a fancy new age editor allows you to properly format this string so you can more easily understand what is happening here. All right, now a little bit of architecture or what's been happening. The whole concept has been one of the problems that we have is that we had, or not problems, one of the requirements of the project that we need to finish everything within a certain part in a certain amount of time. So we are going for the producer-consumer architecture, which basically it's like the producer is creating tasks and where the consumer is consuming the tasks. A task basically it's a message which says that that says in very plain terms that okay, a message with a header which says you're going to run this command by name and you're going to use these parameters by name. And that message is then sent into a broker, which basically you can parallelize as a post office, and it's put like in a queue. That queue could contain like millions of messages, and they're waiting for someone to pick them up. So these queues are then being consumed by workers, and they're picking up the first message and they're reading, okay, which function do I have to run? I have to run this function, which parameters, this parameters, okay, leave it to me. So the worker will now know what kind of which function to run and which parameters will go and fetch the data, and they will consume the data, and then will throw the resulting information back to the database, which then will be available to the framework that we use. And I chose as a framework Django over here. If you're not familiar, it's a web application framework. It's made primarily to create websites. It's a fully managed solution. And one of the neat features that it does, it has its own built-in database management system. So it creates tables, it creates databases, it creates everything that queries the data. So everything that gives you all the tools to go ahead to manage, to shuffle through the information that's happening. So me through that framework, I'm generating the tasks. For example, I'm telling it, okay, give me all the listings that they have not been updated for within 1 day. The framework queries the database. The database tells it, okay, there's these 3,000 listings that they are stale. We're creating the tasks, and I am giving them to the post office. The post office then holds in query a queue of 3,000 or X number of tasks that they're pending, and the workers will come one by one, like picking it up and telling, okay, I'm on it and finish it or not. So it's a little bit, might sound a little bit complicated to people that have not done something similar. So as I said, it's I will go into something more hands-on. So throughout the slides, we'll demonstrate the following steps: how to install and configure UPDC, that platform. How we can create an area of interest that we can use for data collection, and to discover listings within that area of interest, the details about the listings, calendar information, reviews, and maybe booking codes, and also how to configure it for scale and production. Well, without further ado, let's go into that. It's obviously, we have now just going to scroll down that, and we have set up a virtual machine with already we have Docker here running. We got Git, and we got all the fancy editor and the database connection I was telling you. Obviously, the first step is to come. The first step is always to download the code. It's if you are familiar with GitHub, you can clone the code with something like that. So git clone the URL that we spoke before, and that will clone it to this folder. I already have done this step, so I will not do it. In this folder, and here we now have all the code that runs that is on our GitHub. Exactly a carbon copy of what we have. So the first step, obviously, as I said before, everything is run through the through Docker, through containers. So the first step, and going with this diagram, the first step is that I'm going to create like a database, and the brokers, the post office over here, which basically are not optional, it's embedded, but it doesn't mean that you have to use this one. Maybe you want like to use your own database or a more a bespoke database that you have over there, instead of creating a temporal one that like me. And also you at the end how you can do that. But basically you need to change the configuration over here where the database is, but that's not of importance now. So the first step is obviously to create the broker and the database, and you do that very easily by issuing this easy command. So docker compose, we have the compose files which basically contain all the instructions of what this service should be, and up or generate these two services. These two services are the database and the Rabbit, which is like a broker. And we press the enter. We are creating it. The database, it's made. It creates a sparsely enabled database, and then you can see also the Rabbit here that the broker that is also activated. After a little while. It will calm down. This is like just the logs, and that is when you got the database, everything up and running. So I'm opening a new tab, and I'm cd to the new folder, cd Airbnb test, and if we go to the database, here's the DB Beaver database client, and was able to connect to our local host in the port 5432 in the Postgres database, and basically it's empty, doesn't have any tables. So to remedy that, our application needs a number of tables that it's going to store the data inside. To do that, we need to do the next step is here. So we need to create the tables. To create the tables by issuing this command. Basically, what it does again, it's we are issuing telling Docker to run an instance of the worker, and with that instance to run the migrate command that will migrate the state of the database from the current empty state to the final one that has all the tables, all the empty tables. Excuse me. So here we're getting an okay. That's basically we're creating a number, the tables that we need for our operation. If we refresh this one, we'll see all the tables are here. All of these tables, they're serving a purpose, but we will explore a little bit. But basically now we have everything. We have a fully functional database with all the tables that we are supposed to have. And more importantly, these tables are 4 of them, they are sparsely enabled, which, again, apologies. I need to figure out how to. Okay, I need to close this one. So more importantly, it's that this database, it's sparsely enabled, as I was saying, so you can connect with it with your favorite GIS client. And we'll give it a second here for QGIS to load. In the meantime, okay, so this is the world over here. One of the things that we've added over here is that let's do them together. Here so the client correctly recognized that it has 4 sparsely tables here. Save. Create, save, yes, this one. So one of the things that we want is the application is built that basically allows you anywhere to define an area of interest. If you remove this one, if you can define the area of interest by opening QGIS and then loading the OSA table, and you can draw a polygon where you say, okay, I want to I'm interested in this location. For this demonstration reasons, you could I would go to Jersey. It's a small island, which is very limited and it's very suitable for our demonstration. And basically what you do is you're creating a polygon over here. You're adding the attributes that you need. Jersey and timestamp. You're telling it when. That's one thing that you suggest. This one should be automatically put, but it's not. And then you are telling it how this polygon should be used. So are you going to use it to collect the calendars? Are you going to use that to collect the listing details? Are you going to collect any reviews? Are you going to use it to scan for new listings? And are you going to use it to collect bookings? No, I'm not going to use it for that one. So basically we have it over here. And this is our number 1. If we click here, we need this number. Not, no, really. But one of the things that I want to tell you is that as the application is made that could work globally, the one thing that you need is like to define which areas are lands, are valid, or not. So basically, you need a mask of the land areas, and that will filter any kind of requests that will not happen in the sea. So you're going to be saving some bandwidth, you're going to be saving a lot of like in the long run. And to load the mask, so again, this one, to load the mask, it's what we're doing. It's that we are downloading the data from the JDM. JDM, if you're not familiar with it, it's a website which from a certain university that they collect all the world boundaries in certain levels, and that they're creating and they're giving a data set with these defined world boundaries, and just using that as an input to create the mask. And also, since they are kind enough like to give it to have some information about them, you can define for which country. If you don't put this parameter, the ISO parameter, it will do the whole count, the whole world. But if you specifically say that I want for this country, then it will do for that country. If you do for all the country, for the whole, if you do for the whole world, it will take like about 10 minutes or so to add all the information. So it's not really, you could do it, but we cannot do it at this moment. So just for Jersey, if I want to add, again, singular command, Docker compose, I'm going to load these 2 definition files, and I'm going to run an instance of the worker, and we're going to run the command load mask, and I'm going to tell it to load only Jersey. So if I press the enter, it's downloading the file. Hopefully, thankfully, we have like a good internet connection. That should take only a couple of minutes. Yesterday, today. Oh, come on. Okay. Yeah, today's internet is not very good. Yesterday it took me like start to pick up. The file, it's about 1 gigabyte on size, so it will download the file, and then it will import all the boundaries for that for the count that we told, and that these boundaries will be used as a mask. It's quite important because otherwise it will just say I cannot understand anything over there, and it will filter everything that you try. It will filter out the areas that you try to harvest. I will finish all that. So here we download the file, and we extract just Jersey, and we can see it here as an entry in our world shape file. Excuse me. So that knows that Jersey over here is a valid area. So whatever you make over here, it's going to be processed. Now let's change this a little bit. The display, the symbology. Let's make the feelings. Make it transparent so we can see what's happening here. So the next step is let's go back to presentation a bit. So we defined an area over here. So one of the things that is not the next step that is happening is that if you remember before, it's that we have internally it's going to generate grids, and if you remember from before, it's that one of the things that we added, it's the ability to talk to the Airbnb through the API using coordinates. So we can tell it to give me all the coordinates, give me iterate all the homes that they are within this bounding box. So the next key thing that we've been doing is that we are generating grids boxes or bounding boxes inside this this area of interest, but they follow a specific order, specific logic. Since we made like for the whole world, it's one of the logics that we've been using. It's that we're using the quad keys. If you're not familiar with quad keys, it's a data structure which, if you take the whole world and you divide by 4 tiles, 1, 2, 3, 4, that's the level 1. If you take the first one and then you divide it again with 4, you got 0, 0, 0, 1, 0, 2, 0, 3. If you take the first one again and you are divided again by 3, you got level 3, and you got 0, 0, 1, 0, 0, 0, 0, 0, 0, 0, 1, 2, and 3, and etc. So you can go all the way down to level 15, and where you will have these boxes in this level, and where you can divide it extra, and you can divide it even more according to your needs. So for our, that's basically what we're doing. It's let's go again with that one. So we're going to prepare our initial grid. So the initial grid is basically, okay, find me the best grids, quad grids that they fit within this bounding box, and put them into the database. So the code has this, the logic is embedded in that. So basically you need to kickstart this operation. You're telling it run this worker container, and prepare me the grid for area of interest 1. That's the number 1. That's the area that we defined before. So if we press the enter, and we'll do the things, it gives me some generated initial grids, and pardon me. And if we do that, there we'll see that initially we have only these 2 grids. We'll change this to outline green. Okay. So these 2 grids could be used to identify to query Airbnb to give me all the listings on that. But since we do have like a problem, like we talked before, it's Airbnb is only giving you bulk listings that not the listing, the results are only are limited to 300 top results. So you don't have any guarantees over here that this listing, this bounding box will only have like a less than 300. So it's going to be a little bit more. It's a bit abstract of you're not certain, but you're getting everything that you need to get from there. So one of the things that we need to do is like to divide. Empirically, I found that the search results are coming back faster if you get have like around 50 results, 50 listings, and the code over here, what it could do does is that it can ask the Airbnb, ask how many and only how many listings we have within this bounding box, and if it has like more than 50 empirical value, divide these children. If it has like a less than 50, it's fine, leave it like that, and do it now. And until this finishes, basically it's a way of dividing or bringing down the queries into a more manageable, not the queries, the target where we're going to run a query to bring it in a way, in a level that is more manageable. So this also could work in very, very big areas. So I don't know if you can see this one, but it's really annoying. So for example, you could do something in in a more bigger areas other than Jersey. Like this is London. So that I did like a while back. So it's great. Imagine, not imagine, it's great. At that time that I did it, had at least, no, at the most 50 listings inside. All right. So, and the interesting thing about this data structure is that you could use all of these levels as they are, and you could cover the whole world without having any overlaps. Okay, this is quite important, interesting. So expand. Imagine that you are not looking London, you're looking not Jersey, you're not looking London, you're looking like at the Great Britain, you're looking the whole Europe, world, whatever. The approach would be the same. We go back to that, and if we go to this one, so we have sensed this one hopefully finished. If we move this a little bit, it did. No, it didn't do it. Oh yeah, for this command I need like to fire up a worker. Basically a worker is if you remember before, it's so far I've been doing the commands in line. For this one I sent a work order to the broker, and it's waiting for a worker to pick it up and actually do the sensing. To do that, worker no, yeah, this one. Yep, Airbnb. So here the worker, this is interesting. It's I opened the worker, and the worker understood, picked up, connected to the broker, and the broker gave it this function, this task to do. Where is it? Okay, with this ID, and it start doing it. One of the tasks basically give us like 3 tasks, as many as grids there are. So for each grid that the initial grids sends how many listings there are. So for this listing with this queue, this quad key ID has 108, so it's more than 50, divided by 4, and sends for this for this new 4 ones, if there are like more than 50 listings. If yes, then divide and move on. So if I move it a little bit, you can see that, okay, all of these listings, all of these grids, they have like a less than 50 ones. And if we wait for a little bit, okay, so everything. So if we open this database, we will see that, okay, these 2 grids are still pending. So for all the ones that we already have, we have an estimated number of listings, how many there are. And I'm saying estimate because there is a way for Airbnb to ask it and tell you, okay, give me back all the metadata only, not the actual data. Metadata means that how many listings there are in your query, and when did you do the query, all these, which engine, which node ran your query, etc. But not the actual information about that. That's to save some bandwidth. All right, so after we did all the grids, yep. So now that we did all the grids, is it? Okay, now that we did all the grids, we are certain that these ones are, it's greater than they have like less than 50 ones. And now we're ready, we have an optimized grid network, which again contains less than 50. So the next step is to tell the application to discover all the listings that we have. Again, with send command, we are telling it using Docker Compose, use the worker container image and send a task to the workers and tell it to discover all the listings. What it's going to do, it's for its grid, it's going to run the query, this bounding box, give me all the listings, and then it will extract information, and it will do some processing and add them in the database. So we are issuing the command, the job is submitted, the ID of the job is this one, the worker picked it up, and it tells us, okay, this is a problem that I'm having in this virtual machine. VPS, worker. Okay, there we are. So for what's happened over here, for all the grids, it says, okay, find me all the listings in that grid, and here the command is coming back, and for this grid I found 22, for this grid I found 49, and etc. For this one I have some duplicates, I already have seen it 0 minutes ago, and it keeps adding. So if we do this, if we enable the layer with the listings, we can see all the listings here, which is very interesting. Immediately we start to have some kind of sense of information with Airbnb, what's happening with Jersey. It's means like a Jersey, it's most of the listings over here, they are within this area. Okay, and you can find some of this route, left and right. Now there's questions for post-processing, how are you going to use the data? Pardon me again. So this is step one. Now we have a feeling of how many listings and where the listings are, and most importantly, we have the listing IDs. And if you go to the code which says describes the API, how you connect the API, most of the endpoints of the API is designed that can accept the parameter, the listing ID. So you can ask the API, okay, give me the listing details for the listing with a listing ID X, Z, or in our case 21, 1, 90, 36, and that will give you the listing details, the information about what this listing contains. And we can do that as well. Now, since we define an area of interest that is interesting, that we're interested at, so we can tell, okay, give me all the listing details for all the areas that we are of interest that we have enabled to look for, that we're interested to get all the listing details about. Again, we're issuing the command of the framework over here created a number of tasks. Here are the tasks for the listings. We have a number of listings. I don't know how many we have. There's a count. So future count. So we have 200 listings in all of Jersey so far. So we made 200 requests, and these requests for its listings go to Airbnb and come back with the information about what's happening with the listing, with its listing. Now, if we see here's what's coming back. Now, here's the interesting thing. I mean, I do know about the listing details, but what is actually in it? So in technical terms, what I get back is a response object. I'm requesting information, and the API is responding with some information. And I'm storing that responses into the database. And this table, no, it's a big one. This one. So I am storing this database, these responses back into this table, which has all the interesting things that you guys might be interested with. And Sublime. So if we take the response, it's I'm saving it as a JSON, as a document. And so if you take the response over here and I'm going to copy the text representation and put it here. It doesn't. It's very big string. So that's why I was saying that we need more fancy we need a fancy text editor, so we can format it regularly. And we go in, say create format. Go back to it. All right, here we have interesting things. Here we have the details about this listing ID. The listing ID is this one. It has this coordinates, longitude and latitude. It's in the city of Jersey, in the state of that, and these all the photographs that they have. All these data are used again for Airbnb's website to hydrate their templates to create extra the features that you see to create the responsive website. Other information it's that we have. The host allows to book it for 21 nights, and you are only allowed like to host it for the minimum amount, like 2 nights. Who's the host is, that's the ID, Sarah, and yeah, that's her URL for a picture that's uploaded, and what kind of label that room has, a 3-bedroom place, and has these vanities. Allows pets, no. Allows events, no. Well, all you got like a dictionary of data with information that keeps evolving as things evolving. I'm not sure if they have COVID. No, they haven't done. I've seen in some places that I've seen in some places COVID-related information that you can harvest and then surface to do some analysis later on. But anyhow, yeah, as I just pressed F5, so the same ID, the same thinking is happening. For this 200, I have one worker that tries to that collects information or listing details about these 200 listings in Jersey. And they took some time over here to complete. I mean, you see that this request took 2 seconds, this one took another 2 seconds, that one took 3 seconds, and etc. So if you go like 200, it would take many minutes. If you take, if you have like 1,000, it would take many hours. So one of the things that is interesting is that using this approach is that you can seed the environment ecosystem with more workers that they work in parallel. You can have like a make all the application of the request in, concurrently. And to do that, let's go again. What we could do to make more scale. So again, I'm telling it instead of just having only one worker, I want to have 2 workers, or let's have like a 3 workers or 10. I'll give it scale. No, scale, please. Yes, thank you. I'll give it 3 workers so we can run a little bit faster. So basically, what I'm creating over here. So what I'm creating over here is that. Come on. Okay, so I am putting another 2 workers over here in the ecosystem, and both of them, now 3 of them, they connect to the broker, and they are asking for a request for tasks to run to command, and all of them they are doing it individually with each other, individually without interfering with each other. There's some other interesting things that with this technology, with this architecture, is that if one of these workers fail for whatever reason, the task is becoming outstanding, and the broker knows, okay, I should have get a result from the worker X, but I never got it, so I assume that he died, so I'm reissuing the task for another live worker to do. And yeah. And basically, what interesting thing you could do, local host. We can we have a visual Rabbit. The broker has a web interface that tells us what's happening in their queues. So Rabbit, Carrot, all of this. So here we can see still the outstanding tasks that they need to happen. They are pending, so we still have another 112 workers, sorry, tasks that they are but they are still in line until that finishes, and they are coming back with takes like a little bit long time, so I'm just going to just put another and make it 10 blockers. So things a little bit faster. See how? Oh. So basically, I'm having 10 concurrent workers bombarding Airbnb, bombarding Airbnb and asking details about everything. And here we can see it. Here we got the remaining tasks. They plumber like a much faster. We still have like 54 to come back, 48. 38, just 20. Yeah, I wasn't expecting to take that long. Last time that I checked, I did this scenario, Jersey didn't have that many listings. 6. And we're done. Well, almost. Yeah, and if we open again the responses table over here, we could extract all the information and mass of what we want of the listings that we're interested with for. Obviously, getting the listing details, it's just one aspect of the things that we want to get. There's particular interest on the calendar, so the same idea applies. We have defined, we have defined in our area of interest here that we want to use it to collect all the calendars. So again, what we do is issue the relevant commands. Which one? Don't stop everything. This is very annoying. It's dragging the wrong. Look folks for a second over here. Things are happening when you press the wrong button in the wrong time. I just close the database. Yep, and come on. What we have here, we call the database and the Rapid is running. Okay, so what we want to do, let's go worker to 1. Yep, we got okay, so let's open the new one. Airbnb test. So as I was saying, we can collect the calendars as well. Another bit of information. The calendar says for Airbnb context, it tells. We'll give it a look in a bit. And again, we apply for that. So for create task, so the framework is creating for its listing task to get a calendar. Airbnb is trying to fight on us. It's 503 are not giving you access to it, so we are rerouting our result. We're rerouting our query response request through our proxies, and we defeat it a little bit. Let's say in quotes, and we're getting back the results, the responses that contain the calendars, and we can see them here. Obviously now the response table is starting to get a little bit big, so we got also the type. So we go here for type calls. So we got all the information, we got the response about the calendar of that listing ID. If we go to that, let's go to this one again, copy and paste, JSON. pretty, and we got a nicely documented JSON response that has all the information that one might need. So, for example, for this listing ID, to close it, I'm going to go like this. Yeah, it's going back. I mean, it's a bit hard to navigate here if you don't know how to do it. But basically, what it tells us is that listing ID. Interesting. So what's telling us that for this date, it's the price was 64 units of that local currency, which was Great Britain pounds. That's what they have in Jersey. In different countries, they have different currencies, and I'm sure that you can say that this is quite structured. You can get information, although it's a little bit bigger information, too much information, so you might have like problems like getting value out of it. Thankfully, an interesting tip like I share with you guys is basically that you could use JSON paths to extract the info that you want. A JSON path basically it's you can give instructions. There's libraries that they can do that in Python and other language that you can give instructions to extract the information that you want from a document. Now, let's say that you want to see all the dates that they're available. You could write the appropriate description, and the query for that library to use that would navigate through the JSON and extract all the pieces that you need. For example, that if you want all the dates, you want all the days. You tell it double dots, give me all the days and the top one, and I want all of them, just them, and from that one I just want the date, give me all the date on the right, and if it's available. So yeah, you got a much easier structure that you can work with. So you can divide it by due. So for this date, it's available. For this date, it's not available. Sorry, not available, not available, not available. For this date, it's available, etc. You could do more fancy stuff to an extent, though. So you could go for let's go all the way down and go to the price node. Here it is. Here we got like another nested environment, and here from here I want all of that. No, I want from here. I want the date, and I also want the price. Date, price, date. It's local price. Yeah. So for that date, it was 64 pounds. That date, it's 95 pounds. That one is 115 pounds. So you see how as the summer is progressing, the prices are becoming more steep. As the summer is finishing, the prices are becoming smaller, lower, and with the limit. With the list price, it's like 64 pounds for that particular list. Now that's starting to become more interesting over here. Still, we have not finished all. Scale 10 workers. Over here, so we can finish this one faster again. Let's go back to this management. We still have 148. What do I want to tell? Okay, until this finishes, let's talk another aspect that we could do. Another piece of information that I've added here. I'm conscious of the time, so I'm going to show the other interesting thing. It's that the reviews. Reviews are basically reviews about an early listing, which contains the review of if it was good or if it was not good, but also who made the review, the reviewee, to whom, and for what listing. And also we do have this we have this approach, not this functionality built in, and I could tell it like to do for all the listings, but that could take an awful amount of time, since for its review we also have the guys, the people that they made that one, and we have a different table for that. We're collecting the data for this as well. So instead, I'll tell it to do the review for just one listing. Hopefully it will finish. I'll just open a new one here. CFC, so this is the listing ID. Obviously, I don't know if that exists or not. So I'm going to take this one. Actually, I don't know. It's very remote. Maybe it doesn't have anything. I'll take this one. Copy. Yes, it does. It did work. So I'm telling it like to fetch reviews for this listing. The system understood what I want to tell. Again, use the worker, right? So fetch worker, okay. So yes, let me. So what it did, it fetched, it connects to that Airbnb listing, and it made this. It found this number of reviews on it, and if we go to that, I have an extra table for this one. So if we go to that listing, to that table, we can see all the reviews. So that's the review ID, when it was made, when we entered it in the database, or same time, today, and what's the text? Brilliant property, perfect for us, the ability to cook, and etc., etc. Who made it, for which ID, which recipient, to whom, and what's the response for it. So for the reviews, we have two pieces of information. We have the actual reviews, the text, which contain information, things, and which language it was made, and who made it. Hopefully, yeah, okay. What is happening also is that the system, whenever it finds a new user that we have not encountered before, it asks it creates a new task and asks Airbnb to collect the data from the user's API and put them into our database. And since we have made 10 workers over here, it was fast enough to harvest all these users in this small amount of time. So for that, what sensational is happening is that for that listings, we have these 38 people that they have interacted with that one. And that's all the public information that we collect from Airbnb API, that the first name, what is about, how many listings they have. Some of them users are hosts as well, where they say they are from. That Stephen guy is from London, and how he has verified himself. He has verified using an email, phone, and Facebook. But what's the picture UI? We're not storing the URL, the pictures per se. We're storing the URL to that picture. And when he made his profile, when we entered the profile, and when was the last time that we update that profile. And we click to that one. Here we can see the photograph of Stephen. Hi, Stephen. Hopefully I was allowed to do that. If not, please ignore it. And yeah, basically, then you can collect, if you having this piece of information is quite interesting, because you, besides of the user, for the reviews, let's go back. So you can see when this review was made, and if you group all this one, you can see that in 2000, the first review was made in 2016. It has only one review of that year. For 2017, we had only 5 reviews. For 18, the guy was more popular, had this many. For 19, had this many. For 20, had only this one, COVID. And 2021, beginning of the year, had one. And obviously you can group by months, days, even hour if you want. You can go all the way down, and you could create a interesting graphs to see how the reviews and aggregate that. Take all the reviews for all the listings for all the Jersey and see how many reviews they had for 2008, 2020, 2021, or whatever you want to do. And basically, that is it from me. I will skip all the commands that I put over here are here. Oh yeah, and the bit. So far, what we've done is like we're issuing the commands manually. Okay, give me all the calendars from that area of interest that I told you I want the calendars from. That's not very convenient if you want like a service. So what is happening inside, you also have a scheduler. Scheduler, it's a piece of code that kicks this task, the initial task, the starting task, pre-specified every 4 hours, pre-specified time schedules. And also it's embedded on that. If we activate the mode in activate the framework in the bit mode, that's how it's called, like a heartbeat. So I've set it up in the code. CD, CRC, CD, Airbnb, Explorer, here, CRC, DJ Airbnb, on the this folder, and in this file, mind if you don't have your tools. Okay, so what's happening over here is that basically I'm telling it every 4 hours, at minute 0 every 4th hour, run this command. What the command does is that it's going to collect all the listings for the areas that we enabled it. What this command, again, how many? Up to 5,000. If we have like a 20,000, it only will collect only the first 5,000, but they are the oldest one. What we do here, update the reviews, similar like that, every 4 hours, that all the reviews up to 1,500, that they have an age of, they are older than this many hours, that is 14 days. So you define your own schedule here programmatically, and you're telling it how your service want to run. If you want it, in our case, I mean, I think we're doing about 80,000, 90,000 requests per day, mostly in a couple of areas that we are interested in, and we are generating our data. Let's go back a little bit to my the final bit of our story. Go back to the thing. We already talked about scaling. Obviously, the interesting thing, if you are not familiar with the Docker technology and this Kubernetes and all these main containers and things like that, you're not restricted to run this these nodes, these workers into your computer. You could distribute them around the different nodes. So you can have hyperscalability. You could have, if your computer over here only can support 100 nodes, that's fine. Then buy another Zipcode node, add it together, and then you could have 200, 300, 800. And that's up to me. That's my presentation. The one thing that I want to mention over here is that if you try to do this by yourself, it's going to be very, very hard. Mainly not because of the code, it's like because that we at this moment, the demonstration is using a proxy network. You're using smart proxies through a private company. Basically, what the smart proxy does is that, okay, I'll start from the beginning. Airbnb, when you are bombarding it, a single Airbnb, when it's bombarding it with requests, it starts to throttling you, meaning that it will allow you in the beginning, but after like 3 minutes, 2 minutes, or whenever they're putting it, they're putting you in their blacklist. Let's say they are going to block your request for a certain amount of time. And if you keep doing it, they're going to keep blocking you even more. even more. At some point, you will not be able to get any information until you wait like a couple of hours to go back to the normal operation. So to go around that, the only way like to go around that is like to mask your requests that they're coming from a different IPs. And for us, it's the easiest way to do it. We found like a commercial provider that do like a smart proxy, which basically all our requests are going through them. And the smart proxy, what it does is that I am requesting them to do that. They doing that per my request through a worker, their worker, and if that worker gets banned, then they are redoing it using a different worker with a different IP. So what I get back is like only the correct result, the result. That's not 100% bulletproof, but we have like over 95% success on that, which I'm very happy with it. So if you try to do it by yourself, initially you would be in large scale, especially. So initially you will be able to have some successes, but don't find yourself like a surprise after a point you are going to have a lot of 404s, 503s, 501s. I don't remember what the error code that comes back from Airbnb when you fail something is. Yes, and I know that I've spilled over like 5 minutes over 12. And if you got any questions, I'll be happy to answer them. Now.
Thanks, Nick. That's great. And we have spilled a wee bit over the time, but I thought it was hopefully useful to let Nick finish just with the last few points there. We did have one question just about the API key that we use, and I already answered that in the chat, but for everyone else's benefit who didn't see that, you do not need your own API key for this application. We actually use Airbnb's own generic API key, the one that is used by the website itself in its normal course of operation. And as I've sort of mentioned in the chat there, we're effectively mimicking the behavior of Airbnb's responsive web application, and rather than extracting just the HTML results of that hydration process that Nick described earlier on, rather than grabbing HTML text or you navigating the document object model, we're just going a little bit further upstream and grabbing the data from source via the API. The other question that we've received: will we provide an instruction to this walkthrough session so we can have a go later on? Absolutely. So what we will circulate in the next day or so will be obviously these slides that you've seen, but in addition to that, a link to, which was actually already within the slides, but a link to our GitHub page where you can download the code. There are README files there that outline the installation steps for and point to those resources that are dependencies. So they'll point you to where you can grab Docker and all of the things you'll need to know. Incidentally, this is within a Docker container, as well as scalability that Nick mentioned. It also offers us platform independence as well, so you can run this on a whole range of different hosts as well. So the steps will all be there, so you can absolutely have a go and let us know how you get on with that. But I already invited other questions a few moments ago, and there's no other questions that have come in, and we are over time just now. So I think I'll probably just draw things to a close. I'll thank Nick for the presentation and for the coverage of what we're really excited about as a data collection platform. I'm really keen to hear how other people get on, and thanks very much for joining us today. Please, by all means, write to us. You can contact us at UBDC with any follow-up questions or conversation points. But once again, for those of you particularly in research roles, I would encourage you to register to take part in Thursday's session as well, where you'll see some of the ways that we're using these data, and the possibilities that have been outlined today are finding a really kind of interesting purpose and a research application. But have a great day, everyone, and thanks again.